All right, everybody. So I wanted to do a couple of videos where we talk through a couple of the homework problems in homework number 15. So this is problem number 12 from homework 15, and you'll notice that I took something here. This is directly out of our previous lesson, in which we talked about what we do if the doubling time of a given population is known. So let's read the problem together. A certain species of bird was introduced in a certain country 25 years ago. Biologists observed that the population doubles every 10 years. So I'm actually going to go ahead and highlight that. We know that the population doubles every 10 years. And now the population is 23,000. Notice the 23,000 is in red, which means the different ones of you are going to have a different number there. A, what was the initial size of the bird population? Round your answer to the nearest whole number. Obviously, there can't be fractions of birds. And then B, estimate the bird population 9 years from now. Round your answer to the nearest whole number. Okay, so in this case, we know the doubling time. So I'm actually going to go ahead and here, I'm going to write, we know that the doubling time, which we've been calling capital D, is 10. Now, what you do with this formula, with this whole process, is kind of your call. I'm guessing many of you will memorize it, and that's fine. I'm just going to really quickly write here that what this means is we know that whatever the initial size of the population was, we don't know it, and it kind of doesn't matter. We know that 10 years later, it has doubled, right? So here, D is time. So I put T in place of time, and K is my growth constant, or my relative rate of growth, and I don't know what that is, but doubling time will tell me, right? So this is where we talked about the fact that you're solving an exponential equation, so you divide both sides by A0. So you have 2 is equal to e to the power 10k. So taking the natural log of both sides. And I'm not going to talk through that whole part because we've done it so many times before. But what you see here is that the rate of growth is the natural log of 2 over 10. So this is something that we talked about in our previous lesson, but we didn't use exact numbers. However, that's how we end up with this, right? That the formula for the amount in our population is A0 e to the power natural log 2 over D times T. So K is natural log 2 over 10 because doubling time is 10. So I would encourage you to go through this process of finding the relative growth rate at least a time or 2 or 3 until you start to see why when the doubling time is known, you can kind of skip straight to the chase and say, okay, the formula that models this population growth is this. A0 e to the power natural log 2 to the power T over D, which we can write more seamlessly as A0 times 2 to the power T over D. So I really recommend that you walk through that because otherwise if you're just memorizing a formula and you don't know what it is, that can be problematic. Okay, so now let's get to answering the questions in the problem. What was the initial size of the bird population? So of course the initial size is A0. Okay, and we know that 25 years ago, this population was introduced, and now the population is 23,000. So we know that 25 years after the population was introduced onto this island, it has grown to 23,000. All right, so we know that when T is 25, A is 23,000. Right, the actual size of the population is 23,000 after 25 years. So what we can say here is 23,000 is equal to A0, whatever it is, times 2 to the power 25 over 10. right? So again, I'm plugging 25 in for T and 10 in for D in this formula. So all I need to do, since 2 to the power 25 over 10, that's an actual number, all I need to do to find A0 is I need to take 23,000 and I need to divide that by 2 to the power 25 over 10 or 2.5, whatever. So let's punch this in. And I'm going to punch it into my calculator, but I kind of want you to notice, right? If the population doubles every 10 years, that means that it's doubled twice and it's halfway to doubling a third time. So you can sort of think to yourself what would be reasonable. For instance, if we started out with 7,000 birds, well, if it doubles once, that's 14,000. If it doubles a second time, that's 28,000. And then more, right? So if the population started at 7,000 birds, we would be at way more than 23,000 birds 25 years later. So you're expecting a relatively small number of birds because after it doubled twice and then some, it's only at 23,000. So kind of try to think to yourself as I'm punching this into my calculator, what would be a reasonable number here? Okay, so I'm taking 2 to the power 2.5. Okay, and then I'm dividing 23,000 by that. And the number I'm getting is 4,000. I'm getting 4,065.86, but it says round to the nearest whole. So 4,066 birds. Okay, so this is kind of in line with the number of birds that we were expecting, because again, this is a number that would double twice and then some and end up at 23,000. Okay, estimate the bird population 9 years from now, okay? So remember, now is 25 years after the population was introduced. So that means that this is 34 years after the introduction of this species. Okay? So T here is 34, since the bird population was introduced 25 years ago. So it's already been here for 25 years, and then 9 more years puts us at 34. So now that we know the initial size of the population, it's 4,066. That's A0 times, and again, you can use the base E or the base 2, but base 2 is a little cleaner to write. So T here is 34, and then doubling time is 10. Okay? So now, let me point something out to you before I start punching this into my calculator. 9 is almost the doubling time. It's not quite the doubling time, but it's almost, right? And we know that this population doubles every 10 years. So what would be reasonable for us here is that the size of the population close to doubled from its current size of 23,000. So we're expecting a number in the 40s of thousands, right? Not quite 46, but close to it. So if you get a number that's in the hundreds of thousands, or if you get a number that's like 200, both of those signal to you that something went wrong. All right, so here goes. So 34 over 10 is 3.4. So I'm going to raise 2 to the power 3.4. And then I'm going to multiply that by 4,066. So sure enough, I'm going to round to the nearest whole number. The number that I'm seeing, the number that I'm seeing on my calculator is 42,920.95. So I'm going to round it to 42,921. So again, this is very much in line with the number that we were thinking. We knew that since 9 years is close to the doubling time, that we're looking at a number that's very close to the double of 23,000, but not quite. Last but not least, sketch a graph of the bird population, okay? So notice that we have 3 data points here. We know the initial size of the population, which is about 4,000. We know the amount of birds 25 years after the population is introduced, which is 23,000. And we know that 34 years in, we're looking at about 43,000. Okay, so right off the bat, this first one is out, right? The initial population here is close to 10,000, and that's not the size of our population. The same is true for this last one here, right? The initial size of the population is quite large, whereas ours is 4,000. Both of these two have the right initial population. Now let's see, for this one, 25 years in. So 25 is halfway between 20 and 30. So that's about here. Okay, so there we are. And if we go over, that's too many. There are too many birds 25 years into this population. So if we go over to 25, now the picture is cut off a little bit here, but you can see if I find 23,000 on the number of birds and I go over, you can see that that's believably 25 years in. So in fact, this one is the correct graph. This is the one that most closely aligns with our data points. Okay, so this is the graph. And again, all I'm really using to determine which one the correct graph is the initial size of the population and what I know the population to be 25 years in. If you wanted, you could also check for 34 years and see what that gives you to make sure that lines up. But we didn't even need to do that because the 2 that we were starting with gave us enough information. So that's this problem. I'm going to make a couple more videos for a couple more problems from this homework, and I will see you later. Bye.